All right, hello. My name is Juho Syrjänen. I'm from Finland, here to talk a little bit about platforms on a very, well, non-native workload on our platform. I gave the same speech or talk in KCD Warsaw, so this is kind of like very much of a speed run, so bear with me. So imagine the worst possible workload on Kubernetes. Most of you probably think about AI, but I'm telling you it's games. Here's our game. It's a bunch of different stateful pods that run our mobile game backend. So real quickly, why do the games actually hate Kubernetes? There's a few different reasons, but traditionally games are notoriously kind of not happy to restart. You deal with a lot of these player states on the pods, and it's often kept in the server memory. So what happens is that if the server essentially restarts, you lose players, they lose their sessions, and you get very angry clients. Then we have really high tick rates, so the game client communicates with the backend around 1,000 times per second, and if you start to offload the reaction into a database, it becomes very costly, especially if you think about network transfer costs. But always, not all game servers are stateful, but when they are, it's horrible. If you're running games and it's not stateful, then you're in good. So another thing is we have the distributors, which is kind of unique for games. So where every single build we push to the clients is gate kept by Apple and Google, and our backend essentially could move fast, but the client can't. So this whole DevOps thingy that we've been hearing about for the last 10 years is kind of broken. It just doesn't work. And then we have the games industry, which is incredibly competitive as well. Games literally blow up overnight. You run an ad campaign, your game gets featured in the App Store page. You need to scale up 200 times the players, and then you're essentially well, kind of in a very annoying situation because you haven't spec'd your game server to be actually serving that many players. So players demand new features, competitors are one click away, so if our game essentially goes down or we can't scale, they just click another game and they're away. And of course, a lot of legacy here, so that goes back to the whole idea that when we start out the game, we test a new build, we test something, do a little test. Some games work, some games don't, so we kill them, some things go forward. We're stuck with this legacy SDKs, and re-architecting a live game with thousands of players online all the time is really hard. Downtime for a game is super expensive. It's tens of thousands of dollars per minute. So we kind of, as a platform team, inherit this fragile foundation, and tech tip kind of builds up. There are some solutions, good news. Even back in 2012, ArenaNet, the guys behind Guild Wars, did distributed microservices on game servers. They had really cool tech. If you're interested about that, check out the GDC talks they have. One of the coolest things in game dev 10 years ago, over 10 years ago. So, but what we have, unfortunately, we have the monolith, so we don't have the cool things from ArenaNet. But there's some hope. New frameworks coming out. So Agoni's from Google extends Kubernetes with CRDs. Orleans from Microsoft is like a distributed way of dealing with players, actors on a game server, and even AWS makes their little blogs about this. So everyone is kind of acknowledging like this is a problem. But of course, we are a platform team. We can't really fix the game. So this is us. We're not happy. But our synopsis essentially is that we want to build a modern platform and make it work, but our workload kind of hates it. So what can we do? Do we even bother? But my answer is it's not just game servers we run. This is actually kind of a simplified architectural image of our platform, how it works. But the game servers are essentially just one little box, so we have a bunch of different shit there. So for a platform team, it really makes sense to consolidate things, so another architectural picture of the game. It makes kind of sense for us to consolidate everything under one layer abstraction, and Kubernetes becomes that quite naturally. So another little picture of my production cluster. You can see it's not optimized, right? But we are always preparing for the live events, the game to scale up, and because we can't restart our server, we're kind of in this situation. It's not perfect, but it kind of works. So my question is, how do we move from this into this? So our monolith into microservices with 24/7 uptime. The answer is we don't. Instead, we ask how do we suffer a little less. So I want, as a platform team, to be able to sleep at night and be able to still be happy to build our platform while we have this horrible tenant. So few ways, really simply, how we do it. We kind of identify the key components that are responsible for the disruptions of the player connections. So you can think about maybe pod rotations, node rotations, CNI upgrades, things like this that could affect the player connectivity or kill the pod. So we start to isolate the troublemaker, and troublemaker in this case is the game server. I guess the first thing very naturally is to dedicate a node for it, so you don't really put it next to a noisy neighbor that can essentially cause any disruption. So we have a disruption budget in Carpenter and a bunch of different nodes that are running in Carpenter separated or dedicated node pools. And the game is of course open to everywhere, right? TCP port open throughout the load balancer, so it's open globally. And as I said, a lot of legacy. I think last time I checked, the number of CVEs critical was double digits. So we don't want it to leak out as well, because the cluster, you know, we have other tenants as well. So we kind of want to keep the game completely isolated within the cluster. So a lot of network policies and a direct load balancer, so we don't put it next to our gateway API controllers or things like this. Direct load balancer straight to the game and build a network policy mode around it, kind of isolated, so make sure it won't make any annoying things for us. We separate our release cadence as well, so the things that are actually affecting the clusters that around the game, we have a separate release cadence, so the rest of our platform can kind of move really fast, but the actual production clusters that are running the live game, they have a little different cadence, and we can actually push out our releases that break the game during the scheduled maintenance of the game. And of course, a lot of this observe alert, we have a observability platform, so we kind of enable that by default, right? And a lot of policies, and the same thing again. We want to make sure that the noisy neighbor situation doesn't happen, so protect the game from others and also protect the others from the game. So this kind of isolation buys the platform team a lot of stability and autonomy. We can still have our little cool platform and do our cool things while the game still lives there. So to summarize, make the platform so good that devs want to use it. We want to give them a platform where they can also grow and develop their skills. So my hope is that in the future, when they keep using our platform, they kind of want to keep on using it, right? The next game they push out, it's going to be Kubernetes native. This is my hope. I really hope it works out, but most likely, well, you know how it is. Some business benefits too. We migrated our live game to our platform from our previous infrastructure, got down the infrastructure-related maintenance time up to 60%, so saved a lot of money for the business as well. Light at the end of the tunnel. There's a little bit of work of the of a trend happening with these guys coming out the door, so Orleans and Agonis. So if you think about let's say GDC, the Game Developer Conference, you start to see a little bit more focus on this, which is nice. But that's about it. Thank you for listening to my speed run.
Awesome. Thank you. Traffic, like, you know, from the game, or like maybe WebSocket. How do you solve that issue, like to go do like, you know, routing, right? Ingress, like, you know, for UDP or you know, like WebSocket, you know.
Essentially, how it works out, we publish the for free through the load balancer in AWS layer, and we hook it up directly to the pods essentially. So there's a service type load balancer which is with AWS, and every single connection to the game server is for free, but the game actually inside it does its own stuff with the ports and whatnot. So it's a mess.
But yeah, UDP, like how about the UDP traffic, right?
Well, we don't use UDP for our game. It's TCP.
How do you minimize latency? How do you minimize latency?
How do we minimize latency? Well, we use Cilium. That has cut out some latency because previously we used AWS VPC CNI, so we saw some network improvements there. It enabled us to lower the tick rate as well a little bit. But for us, our game, the latency is not as critical. For let's say, if you think about like a multiplayer game like Counter-Strike or things like this, then it becomes super critical. But our game is a single player, little story-based game which is quite casual, so it's not as big of a deal. But of course, when it comes to latency, one of the reasons why we use the direct load balancer instead of using the gateway API controller or Nginx ingress controller or something like this, it limits an extra hop. Yeah. All right. Thank you guys.
Thank you very much.
No worries.